Okay, welcome back to our series of math videos. Today we get to discuss formulas and applications. Our outcome will be to evaluate formulas and solve a formula for a specific letter. We'll actually solve some formulas or find out an answer, but we'll also do formula manipulation. So you've probably seen lots and lots of formulas in your math career. Here's a couple. Here's a heat one for chemistry and a perimeter one and force, solving x-intercepts, area of a circle. Here's one to calculate your basic metabolic rate. We'll see another one a little bit later. But formulas are a very, very powerful way that we can determine, given a certain number of variables, we can determine another variable. So for this particular one here, for chemistry, we can determine the amount of heat that something will give if we know what the mass is, if we know the specific heat capacity of that substance, and we determine what the change in temperature was. The nice thing with this formula too, though, is we maybe be able to monitor how much heat is released. We might be able to determine what the mass of something is and the change in temperature, and then if we know all of those variables, we could determine out what the specific heat capacity of that substance was and figure out what the substance actually was. So there's lots of applications for formulas. These are just a few. So today we're going to manipulate some. I've chosen to look at the basic metabolic rate formula, and it's the one that we use with metric. So you may not be able to think entirely in metric, but hopefully you can convert your weight and your height into metric. So here's the formula. To find out your basic metabolic rate, you take your weight, which is in kilograms, and you divide it by your height in meters squared. So you need to find out what your weight is, what your height is. That'll find out what your basic metabolic index is. I guess it's not basic metabolic rate, it's your index. And your index here, if you're below 18.5 when you do this calculation, you're underweight. If you're in this range, you're normal, overweight, obese. Let's calculate what I am. Hopefully I'm not too bad. Anyway, my weight's about 100 kilograms. That's about 220 pounds, right in there somewhere. My height is just shy of 1.8, but I'm rounding up. It's 1.77, so I'm calling it 1.8. And I want to know what my basic metabolic, or my BMI. Okay, so to determine that, I can use this formula. My index is equal to the weight divided by the height squared. So if I substitute in all that I know, my weight is 100, and my height is 1.8 squared. So if I do this calculation on the calculator, it comes out to be about 30.86. We'll round it out to be 31. Oh, so when I look down at my little chart there, it looks like I'm past overweight. I'm almost in this category. Okay, I don't want to say it, but I'm sort of in this category. But I'm on a diet, so hopefully that number will come down a little bit. Okay, so that was a fairly easy one. My formula was already solved for I, and all I had to do was substitute in letters. Let's try one going backwards. So let's say that my index, I want it to be, I don't know, about 20. What's my other range there? Let's go in the higher range. Let's go say 24.9. So say I want my index to be 24.9. My height, can't do much about that at my age, 1.8. And what I'm wanting to figure out is what should I diet down to so that my index is in the proper number. So I want it to be about normal. I don't want the overweight category. I want to be sort of normal. Now, two ways I could do this. I could plug in the numbers first and then solve for W, or what I like to do is I like to solve the formula first for the variable that I'm looking for. So if I'm looking for W, I need to solve this formula for W. So what I want is I want W on a side by itself. Right now I've got this h squared underneath there. I want to get rid of that. So to get rid of that, I can use the multiplication principle that says if I multiply this side by h squared, I can multiply this side by h squared. When I multiply this side by h squared, notice that h squared divided by h squared is 1. It's a factor of 1. And so these, when I multiply w by 1, these essentially cancel out. And so I'm left with w is equal to h squared times I. And so now I have my formula solved for w. Notice that I can swap that formula. If I do a wholesale swap, I can write the formula like this without having to change signs or anything, just if I do a wholesale swap. Let me continue my formula up here. So W is equal to, what I'm wanting is, my height I can't change, that's 1.8 squared, and my index I want to be 24.9. 24.9. So when I multiply those two out, I get, I think I did this on my calculator, 80.67. We'll call it about 80.7. And remember that the weight is measured in kilograms. So I need to get down from 100 kilograms down to 80.7 kilograms. If you multiply that by 2.2, it gives you about 177 pounds. So apparently I've got some work to do. I need to get down a little bit more in pounds to have my basic metabolic index. I think that's what that stands for. Anyway, my BMI down to a normal level. Okay, so that is manipulating formula a little bit. I want to go through just a couple other formula manipulations, just show you a couple other examples. Use your textbook. There's lots of good examples in your textbook on manipulation of formulas too. Here's a good one. Say we want, here's a formula, looks like that's the area of a trapezoid. And I want to solve, say, for, I guess it's already solved for A, but say I wanted to solve for lowercase a. I wanted to solve the formula for that letter there. So what I want in the end is A is equal to something. So right now I have to use my formulas or my rules to get that by itself. First thing, if I ever have brackets, what I like to do, and I'm trying to solve for something in the brackets, I like to get rid of the other stuff that's there. So this stuff. So I'm going to, since this is divided by 2, I'm going to multiply both sides by 2. If I multiply both sides by 2, I get 2 times A is equal to 1 times H, which is just H, times A plus B. Now, I'm pretty close. I've almost got my brackets isolated. I want to get rid of this H. So I can use that division principle. So I'll divide both sides by H. So I'll get 2A divided by H is equal to, if I divide this side by H, those H's cancel. So I'm just left with A plus B. And if that's all I have, I can get rid of the brackets. And then finally, last thing, I want to solve for this A. So I want to get rid of B. So I'll use the subtraction principle. So I'll subtract both sides by B. So I'll have 2A over H, subtract B. Notice that the H is a denominator just for this term, not for both terms, is equal to A. Now I've solved my equation for A. Some people, when they look at this, will say, well, it would be nice to combine these two terms. Instead of having two terms, you could combine them. I'm okay leaving it here, but some instructors might like you to combine those. And if they do, it's a matter of just getting a common denominator. This one has an H, this one would only have a 1, so my common denominator would be H. So this one would still be 2A over H. If I multiply top and bottom here by H, I would get BH over H is equal to A. Then, since they both have H's on the bottom, I could rewrite it as 2a minus bh all over h is equal to a. So there I've solved my equation for a. I'm okay at this step here, but like I say, some instructors like to see on the left-hand side just one term. And you can see how your book likes it as well. So that's one way. Here's another equation. Here's an equation or a formula, and this time what I want to do is I want to solve for the letter S. Now when I look at the equation, one of the problems that I see here is that I've got two S's. In the other equations that I had, when I had to solve for A, there was just one lowercase a there. Or in these formulas, there's just one of each of them. In this case, I've got two S's. And the trick that you can use to solve when you have two S's or two of the same variable is to factor this expression here. So leave R alone and then factor an S out. So if I factor an S out, S divided by S is 1 minus, if I factor this S out, I'm only left with TR. Now notice that I only have one S in this equation now. So this is S times something is equal to R. I just want S, so I'm going to get rid of this. So I'll divide both sides by that, leaving me with R over 1 minus T lowercase r is equal to S. Now I've solved the equation for S. The trick there, though, was to factor. So I could factor an S out. That gives me only one S now. Then I can use the division principle to divide both sides by this, and I have the equation solved for S. One last one that we actually won't be able to solve, but I thought I'd show it to you just as a precursor for your next math class. Here's an equation, and it's you may have used it before. It would be for compound interest. So you have so much money, you throw it in the bank for so long at a certain interest rate, compounded so many times per year. And this is a formula I could use to figure out how much money I would have at the end. If though, say I have this equation or this formula, and I want to figure out how long I'd have to put something in. So say I start with $1,000 and I want to come up with $2,000 in the end. And I say, okay, well, my interest rate is 5% compounded, say, twice a year. So this end would be twice a year. And my question is, how many years would I have to leave that in the bank for? Now, when you look at the equation, let me erase this stuff. When you look at the equation, we actually don't have any tools to do that. I know I'd probably want to isolate this part. So I might divide both sides by P is equal to this other, 1 plus, I over N to the NT. But we don't really have any tools to help us solve for a variable that's in the exponent yet. You will have tools later. I won't show you how to finish solving this. I'll tell you how you could do it. You need to use something called logarithms to help you solve for that variable up there. But it's another good example of a formula in which you want to solve for one of the variables. You won't get any in this particular math class, but later you will get some where you have to solve for a variable that's in the exponent. And to do that, you'll learn all about logs. So today we have looked at formulas. We've looked at plugging numbers in formulas and solving for a variable. And then we've looked at just manipulating formulas to solve for certain variables, and we've tried a few different options on how to do that. Hopefully that gives you some help on doing the questions. As always, you need to practice, 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 do lots of questions, use a solution manual that's posted online to help you see which step you should do first. But practice, 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 and you'll find that these questions will be fine. Okay, we'll talk to you later.